看视频上澎湃。
Hello, dear friends. Welcome to the live stream presented by Sixtone. I'm Sharon Zhang from the paper. In this broadcast, we will show you around SVOLT cathode material factory based in Jintan, Changzhou. Before this, we learned the cobalt-free cathode material, which went viral last year, had achieved mass production here. This means that cobalt-free battery has evolved from concept to reality. Now, as the new energy vehicles develop in full swing, selection of battery types has become one of the key factors to consider for consumers in their purchase. More than half of the cobalt mines are concentrated in Congo due to regional reasons and as a non-renewable scarce resource. Cobalt has remained high in its price. Since Jeff Dunn, research chair of Tesla, proposed the cobalt-free concept, the NEV battery industry has been researching and working hard in this direction. In the end, it is SVOLT that took the lead in cracking this problem. So for batteries without cobalt, is large-scale production and application really achievable compared with the usual lithium-ion batteries? What are some of their advantages? With these questions, we'll walk into SVOLT to find out and see how this cobalt-free battery was created. Now we're in the control room. You can see on the screen behind me the interior view of the production line and manufacturing processes. As we introduced earlier, in order to achieve cobalt-free in batteries, a key step is to make cobalt-free cathode material. Today, we're happy to have General Manager of SVOLT Material Business Unit with us, Mr. Jintan. Together with him, we'll take on the tour through this production line. Nice to see you, Mr. Li. Please join us and briefly greet our audience. Nice to see you. Hello, everyone. I'm Jintan from SVOLT. Next up, I will introduce you to some of the basic facts of SVOLT cathode material factory. Welcome, Mr. Li. Could you please give us some information about the planning and construction of the factory? Alright, our cathode material factory in Changzhou is planned to cover an area of 80,000 square meters. A floor area of 100,000 square meters. It's a three-phase construction, which ultimately could achieve 20,000 ton capacity. Now we have completed phase 1 with 5,000 ton capacity. By end of this year, we'll build another phase of 5,000 ton capacity. By July next year, we'll complete the final phase with 10,000 capacity. So by end of next year, we'll be able to achieve 20,000 ton capacity. It's a step-by-step process. As for you, Mr. Li, have you been doing R&D and production in lithium-ion battery these years? I've been engaged in the development of cathode materials for more than 21 years. Throughout the years, I experienced the nationwide production of LCO. We made LCO, LFP, and spinal LMO, pretty much all kinds of cathode materials. Now, SVOLT has developed a layered structure made of lithium, nickel, manganese oxide. Of course, this is a breakthrough in the world. So you have experienced the disruptive innovation from traditional lithium-ion batteries to cobalt-free batteries. Just now, we also showed the audience the manufacturing processes on the screen. Could you help us understand this from a technical point of view? All right. On the two sides of the screen, you can see the real-time monitoring of our shop floor. In the middle is a flow chart of the entire production. Let me introduce you to the basic processes. The entire production has 7 steps. First is weighing, where we use nickel manganese precursor plus lithium salt and some additives and make precise weighing. Second is mixing. Then we go to the third step, which is also the most important one, high temperature synthesis, where two kinds of raw materials turn into one substance, which is our cobalt-free material through chemical reaction. Fourth step is crushing and milling. After that, the fifth step is coating, to coat the surface of the material with super nano metal oxide. Sixth step, annealing, which is a kind of heat treatment for coating. Then seventh step is packaging. After packaging, we have completed the production of cobalt-free cathode material. So from what you said, we feel that although the processes are the same as those in traditional lithium-ion batteries, the composition and the proportion of the metal contained are different. Yes, the secret sauce is our material composition. Processes are not too different. So the real work is hidden in somewhere we can't see, but we want to have a glimpse of it. So could you take us to the production line on the first floor? Okay, let's go to the center workshop on the first floor. Now we are at the production line on the first floor. So to describe this production line, what are the keywords that you would choose? We are committed to two principles in the design of this production line. One is automation, the other is informatization. In terms of automation, our key equipment is imported. Taking mixing, for an example, we use an Italian brand equipment which could mix materials homogeneous in 10 minutes. Roller kiln that we use is also an imported brand. The equipment is fully automated, with few people involved, except for unpacking and packaging, where we have a few people, so we can barely see any workers in the entire area. Production is fully automated, without human contact. Second, informatization. As we just saw in the control room, all the data in production, material, equipment, quality, etc. is transmitted to the control room through optical fiber. The control room is equivalent to the central brain of our production line, which collects and processes data, manages our production status in real time, and ensures consistency and stability of our production. So in a nutshell, the two key words of the production line are automation and informatization. These are two important features. Yes, let's take a look at the material after the second sintering. This just came out of the kiln. You can take a look at this gray-black material. The particle size is very fine, only about 3 microns, similar to the size of the dust in the air. It is the cathode material after the entire production that we can use to make a cobalt-free battery. Well, there are two more steps actually. After sieving and the removal of magnetic impurity, it would turn into cobalt-free material product which can be used to make a cell. I see. The granular size, as you mentioned, we can see that there are actually some granules absorbed on the side of the box, which are very, very small. You can see it clearly with a microscope by magnifying 2,000 to 5,000 times. Thank you for showing us this material. It's actually my first time to see something like this. It is one of the most important raw materials for cobalt-free battery production. Now we have basically walked through the manufacturing processes of cobalt-free material, and we have also seen the final product. It is only the first step in the long march. Battery manufacturing is even more complicated, or even more critical, which is yet to come. Next, we'll go to the battery production line to see how the cathode material turns into a cobalt-free battery. Based on automation and informatization, this cobalt-free cathode production line is designed and built to realize on-time, real-time traceability and quality control and minimize the influence of human factors. Most of the processes are automated to achieve continuous production. World-leading equipment like roller kiln helps ensure zero emission, making production standard, visual, and intelligent. We can see that the production is basically fully closed. And the factory is also capable of information collection and analysis. Based on the result of data analysis, technical workers could modify product data, improve equipment, and optimize processes. Dear friends, welcome back to our live broadcast. We are here in Changzhou at SVOLT battery factory. Before our tour to the battery production line, we would like to introduce an important guest to you who will guide us through the tour. Mr. Yang Hongxin, President and CEO of SVOLT. Nice to see you, Mr. Yang. Please join us and briefly greet our audience. Hello, the paper viewers. Welcome to our live broadcast. Next up, I will lead as a tour guide to walk you through the production of our cobalt-free batteries. Thank you, Mr. Yang. We're honored to have you show us around the battery production line. But before that, as we see, this is quite a large factory. Can you show us around the overall planning of it? Okay. We also have shuttle buses, especially for factory tour. We can take a bus and see it around. Okay, please. Feels like a school bus. This is our special bus for factory tour. As we see, this is a large factory, and I'm curious, could you tell us a little bit more about the planning of the factory? Okay, our factory covers an area of 800 mu and is constructed in 3 phases with a total capacity of 18 gigawatt-hours and investment of 8 billion RMB. Now we can see phase 1 and 2 are completed. Phase 1 with 4 gigawatt-hours is operational and has supplied tens of thousands of vehicles. What we're going to see is phase 2. The first production line with 8 gigawatt-hour capacity has been operational. Phase 3 is under construction with 6 gigawatt-hour plant capacity. It will be completed and operational in April next year, which could produce cells, modules, and packs. For each phase, we have upgraded the equipment. Take the stacking process as an example. 0.6 seconds per piece in phase 1, 0.45 seconds per piece in phase 2, so it gets faster. In phase 2, we also have a high-speed line, which is capable of 0.125 seconds per piece. So it's technological progress and upgrade. Usually, the production site is planned based on products or geography, but you mentioned that SVOLT planning is based on capacity. Yes, the reason why we use capacity for planning is the efficiency of each production line is upgraded over time. Now we're arriving at the battery production line that has many innovative technologies. Let's have a look together.
就从这个入口进去哈。我们先进。进到电池车间之前呢，
虽然是参观通道，但是也有一定的洁净度要求，所以要先经过一个风林室，大概有
风林室
的风林。对，好，我们
有点想到了那个汽车出厂的那个车间上，先好哇，来看一下。哇，好，赶快整理一下，谢谢杨总。赶快整理了一下发型，然后刚刚我们经过了这个风。
Just now we passed the air shower. It is also a preparation step to enter the production line. Yes, because the shop floor is actually a clean room, even though we're walking outside, dust removal by air shower is still required for guests and our workers. What we see now is a key process, stacking. This is our stacking workshop. I learned a little about our ultra-high-speed stacking before, which is a technical highlight of the production line. Could you give us a more in-depth introduction about this technology? Okay, before that, I would like to briefly introduce our manufacturing processes. First is coating, where we apply powder on the aluminum and copper foil, and then rolling to make it tight, then slitting and notching to make it into pieces. Imagine what book pages are like. Then AGV will transport them to the stacking workshop. The equipment we see now is the quickest double station stacker in China. The separator is in the middle. It can stack two pieces at a time, so cathode and anode can be stacked in one go. In phase 1, we could stack one piece at a time like other companies. Now we can stack two pieces at a time, so it's high speed. So the efficiency is doubled, and listening to what you said, I don't know if you have the same picture in mind. I think it is like an egg roll. Roll it and then cut it into thin pieces. Is this a vivid way to see the stacking process? The pieces are stacked together one by one. It's not like a roll, no stress on the edge, and it's flat and prismatic, which is an advantage when it comes to energy density. Stacking process was not often used before because it's slow and not efficient. For example, if 20 pieces of equipment are needed to achieve certain capacity in winding, twice as many would be required in stacking to achieve the same capacity, so it takes more space and investment. So that's why we introduced this ultra-high-speed stacking. The purpose is to save space and reduce the number of equipment. Here you can see the secondary filtering system inside. This shop floor is class 10,000. Cleanliness in general, local areas could be classed 1,000 after secondary filtering. As dust cannot be avoided in stacking process, we use plasma to remove all the dust with ion wind. In this way, there will be no dust in the cell, and we can make sure cell production is safe. We can see that there's an outlet on the outside of the machine, somewhere the air is coming out. Is this the plasma you talked about? Highly efficient filtering system. Next to the stacking platform inside is the plasma dust removal. In this way, when each electrode piece is lifted, there is dust removal. We have many other advanced technologies, including CCD visual detection. After each piece is stacked on the separator, will detect its alignment. Not good enough alignment would potentially cause a short circuit, so the alignment has high standards. Also, if there is some defect on an electrode piece, such as a scratch or an incorrect size, it will be automatically eliminated. We have employed 3 visual automatic detection systems to help ensure each cell is safe. What you said was not only about ultra-high-speed stacking, but many other self-developed innovation of the production line. Yes, this is what we call an intelligent factory. So it is highly automated and intelligent in many aspects, for example, welding, stacking, and big data analysis, which are all leading in the industry. So many aspects, including design, production, and management, all the links to the entire work process, are focused on intelligence, automation, and informatization. Right. We say no touch in cell production, which means the cell is not touched by people throughout the process. Once it's touched, even just a stain could cause lithium plating, and then there would be a defect. So from the beginning to the end, the fewer people, the better. The entire process is to be completed by machine. Cell production is actually very much like cheap manufacturing. Many processes, potentially defective products in each process, sensitive to water, dust, and touch. So among industrial products, battery cells are most suitable for manufacturing with automation, intelligence, and AI technology. With machines used this much, the human brain is focused on design, monitoring, and quality control. Yes, thank you. Now that we've had an overall understanding of the automated battery production line, we have a few other questions for you. We have set up an interview room, and please join us there. We would like to discuss with you the significance of mass production of cobalt-free battery and also look into its future.
请坐。那刚刚呢，我们和大家一起
Just now we visited the 2 production lines for cathode materials and batteries. Here we are in this interview room, which we set up in this factory. We have several more questions for Mr. Yang. As we settle down here, we can see there's a battery model behind us. So can you first introduce it to us? Yes, this battery pack is what we installed on a purely electric SUV, which could achieve a driving range of 600 kilometers. This is exactly the cobalt-free battery produced in the cathode material factory and cell production line. With our long and thin battery technology and cell-to-pack architecture, the SUV powered by this pack could achieve a 600-kilometer range. It is currently the most advanced system design and solution in China. In today's interview, I heard you say first and most quite a few times, including what you mentioned, the most advanced in China or the first creation in the world. So our first question for you, with such milestone R&D achievement, we believe that there have been many challenges along the way. Could you please share with us some stories that are fresh in your memory? Okay, the development of cobalt-free batteries, I think, has filled the gap in the world. It is also a technical breakthrough in China and has core patents. China used to do better in mechanical innovation while having limitations in chemistry or original innovation. Take NCM and LFP batteries that are commonly used. For example, the chemistry system, material, and patents all come from abroad. But in terms of cobalt-free battery, we are the first to make a breakthrough in the world. We have core patents for our high energy density, nickel-manganese layered structure, cobalt-free technology. This is the original innovation in chemistry. So the research and development is very challenging. We have been developing this for more than 3 years. During this time, we first found a theoretical foundation. So it didn't just come out of thin air. There was an article about nickel-manganese layered structure published by Japanese scholars 20 years ago. So we have things like that as a theoretical basis. But for many years, the difficulty has been how to break through technical bottlenecks, including lithium-nickel mixing, gas production, power performance, and internal resistance. Problems like this have not been resolved effectively. Based on first principles, we designed the material from a theoretical point of view. We did plenty of DOEs. Now we told the public that nickel to manganese ratio in this material is 75 to 25%. In fact, to find this ratio, we have gone through a long process of exploration. We went from more than 50 nickel to 90% nickel, from 4.2 volts to 4.3 to 4.35, with different contents, different coating technology, and different voltages. We did more than 100 DOEs and finalized our solution to the current design. After design freeze, we had a very in-depth research and development on coating, doping, and single crystal directions. In the first half of 2020, material development was finalized. The new challenge came to cell development. Material is only cathode material. With new cathode material, electrolyte, anode, and additives would have to change accordingly. Otherwise, we could not find the best combination for the performance. So we did plenty of DOEs on cell level. R&D on new electrolyte formulas, new conductive materials, new anode materials. With our stacking process, as you know, SVOLT is positioned as the pioneer of prismatic stacking when we first entered the field of EV battery. Cobalt-free material has a small disadvantage, which is high internal resistance at low temperature and low SOC. But with our stacking process, which could reduce internal resistance by about 5%, so the combination of cobalt-free plus stacking process enables us to solve this technical issue. We have reached C-sample stage on cell level by far. At the end of 2020, we did a rigorous winter calibration in Hailar, Inner Mongolia. Now we are preparing for summer calibration at high temperature. When the battery has gone through severe cold and heat, the worst conditions, it would get validation on vehicle level. Our development is boiled down to 3 levels or 3 stages: the original innovation of materials, the new combination in cell design, and validation on vehicle level. In this process, we did invest a lot of hardware resources and human resources, including many experts, to break through the technical bottleneck. We also had many rounds of trials and errors. In the end, we pulled through with determination, making success development on material and cell level. Just as you summarized, it's like playing 3 levels, 3 upgrades. You mentioned a term called DOE. Is that some kind of experiment? Can you tell us? DOE refers to validation on multiple design combinations. In order to find the best solution, we need different combinations and ultimately find the best one. A process like this requires huge R&D resources to support and huge R&D investment to achieve. As you said, it was the result of collective efforts that helped SVOLT to lead in the EV battery industry. So, our next question: would the creation of cobalt-free battery be an innovation, a disruption, or an impact on the industry? Correct. In fact, from a primitive point of view, if we try to think of the underlying logic, what kind of batteries are what users and car makers actually need? The answer is simple: long range, fast charging, low price. Production and supply could support 10 to 20 million vehicles per year in the future. These are some basic and simple requirements. We know that NCM batteries that are commonly used on cars have high energy density, but NCM, which stands for nickel, cobalt, and manganese, has cobalt in it. The existence of cobalt is actually not suitable for large-scale applications. About 80% of the cobalt in the world comes from Africa. China is a country with very limited cobalt, so in the strategic sense, what we do not only meets the basic requirements in terms of long-range fast charging and low price, but also helps end the dependence of China and even the world on cobalt resources. So in summary, whether from the perspective of user satisfaction or security of the supply chain, the strategic meaning is momentous. From China's standpoint, if China aims at the commanding heights of global new energy market, our nation must have independent intellectual property rights and self-developed core technology. Our cobalt-free materials and batteries are also able to meet this requirement. This is a major original breakthrough that China has achieved in this field in a long time, which could also help get rid of the shackles of foreign intellectual property rights. You just now, I think, have fast-forwarded to our next question. Your point is to get rid of China's dependence on imported scarce resources, especially cobalt. So SVOLT has made this cobalt-free battery. So what do you think of? I think we can see such an innovation is made in China, right? Because it's completely designed and developed by our own. So could you please elaborate on the significance in that regard? Okay. We can actually talk about cobalt from 3 dimensions. First, reserves of cobalt are very limited globally. Now, more than 1 million electric vehicles are sold every year in China, more than 3 million in the world. In the future, this number could reach 20 to 30 million worldwide. The volume is 10 times of that today. The energy of the battery required to power the vehicle is also increasing. Current cobalt supply is not sufficient to meet this requirement. That's first dimension. Second, the resources are too concentrated in only a few countries and only a few companies. This means that this element is a kind of niche metal and easily be manipulated by the market, so we can see the fluctuations in its price. With this tens of millions of volume, the NEV market is seeking to a stable price and a sustainable supply. So supply is not sustainable, which is also an issue. Third, environmental protection. We hope the car we build when it's running on the road is a truly green and environmentally friendly car. In fact, as we already know, the source of cobalt metal has been controversial in the international community because many companies in Africa mine cobalt themselves and also collect mines from the market. When they do this, it's difficult to avoid child labor. Many companies in the United States receive lawsuits with respect to child labor every year. So from the perspective of environmental friendliness and human rights, cobalt should be removed. So in summary, from these 3 dimensions, supply chain security, price stability, and environmental friendliness, we should find alternatives to replace or remove cobalt. SVOLT, as a startup company, has been committed to doing what should be done at the very beginning. So based on the points I said, we invested a lot in cobalt-free innovation. So we not only get rid of the dependence on imported rare resources, but also accelerate made in China. Just now we talked a lot about R&D and the significance. With this end product of innovation, the ultimate goal has to be how to use it. Many people are very looking forward to the mass production and the application of cobalt-free batteries. In your opinion, for such an innovation or disruptive change, what impact would it bring to the industry? There are several problems that affect the popularity of electric cars. First of all, safety, as we all know. Second, convenience of charging. Third, cost, as infrastructure is built. Charging problem will be solved soon, and we can certainly solve the safety problem as well. The gasoline is also easy to cause fire. At the end of the day, lithium-ion batteries are safer than gasoline, so we can definitely solve the safety problem. Cost is quite a challenge, as it directly affects the popularity of electric cars. A good thing about cobalt-free battery is that manganese is used instead of cobalt. The content of manganese is increased while no cobalt is used, so that the cost can be reduced. Based on our calculation, the cost advantage is linked to the price of cobalt because the price of cobalt has been fluctuating. For example, based on the current price of cobalt, the cost of our cobalt-free battery is lower than that of high-nickel NCM battery, even though very little cobalt is used in the latter, which may be less than 10%. We still could have a 10 to 15% reduction in raw materials. So car makers would welcome such a low-cost solution. Meanwhile, its energy density is high, 255 watt-hour per kilogram, the same level as high-nickel NCM. It also has good charging performance, so battery products like this, with high energy density, fast charging at a relatively low price, could accelerate the popularity of NEV among car makers. So a better alternative for them on the basis of performance improvement, they can get it at a lower cost. Yes, the cost is reduced while the performance is basically maintained. Before this interview, I saw a slogan outside when we walked in here: provide access to sustainable energy. This is SVOLT mission. How do you think the mass production of cobalt-free batteries or the creation would help realize the vision of green energy or sustainability? Yes, we call it sustainable energy. The energy has to be sustainable, whether the source of energy or the materials we use. So we not only work on cobalt-free material or battery, but also engage in energy storage system and partnerships with solar energy companies. Besides, we are also involved in recycling. So from the source of energy to storage to the entire recycling system, we have this connected system that helps ensure sustainability. We also use the cobalt-free material as the carrier of energy storage system. So from internal material to the entire sustainable system, what we do is closely linked to our mission, which is to provide access to sustainable energy. So our R&D direction and what we achieved today are good examples to showcase our commitment to the mission. Yes, thank you for your time again. We learned prior to the show that SVOLT would exhibit at Auto Shanghai this year. Can you give us a little preview on some of the highlights? I'd like to take this opportunity to give advance notice on the Auto Shanghai, which opens on April 19th, where we will exhibit our cobalt-free battery and new safe thermal runaway technology. On April the 20th, we will have SVOLT Innovation Day. I'm not giving details here. Feel free to guess. I hope you can watch our Innovation Day at Auto Shanghai. We look forward to your presence at our booth. Thank you. That is a good pitch. Thank you, Mr. Yang. Here, I would like to invite all the friends who are watching the live stream to join us in the follow-up of mass production and application of SVOLT cobalt-free batteries. Watch us on the paper. Find out more at Auto Shanghai. See you soon.
汽车。
看视频上澎湃。